Today we are going to do first section 4.3, which we're not going to pay that much attention to because I feel that that section is basically extra stuff. But I'll mention it briefly. Okay, let's look at page 374. This is where there is some graph here. Okay, take a look at this graph. And what is the result of something? The question is, can you draw a line across it in order to represent the graph? And in this case, the graph doesn't look very good, right? And your book says that it doesn't really, it doesn't indicate a linear relationship. In other words, you can't draw a straight line to represent the graph. Well, it doesn't indicate it exactly, but you can sure do it, right? I mean, how do you draw a straight line across here to approximate the graph? Well, how about we just draw, I don't know, like this? Something like that. We're just approximating. But anyway, so let's look at example 1 on the following page, where there's a much better system of stuff. Okay, take a look at this. Now this graph looks much more like a straight line can approximate it okay compared to well, some of the stuff. All right. So so then that is what we're gonna do, and as a result, we're gonna draw a line across it. Okay, which then if you turn to the next page, here's the line that the book draw. And this draw, how did they draw the line? They just draw a line by estimation. That is called eyeballing. Okay, and eyeballing means you look at it and you're like, I don't know, maybe like that. That should do it. That sort of thing. That's called eyeballing. And eyeballing does a somewhat decent representation of the data that you have. And as a result, you have, now once you have all that data, and then you have your line that's called, that is with that line you can roughly make guesses. That is, once you have a line, whatever this data is representing, okay, then you can guess that, oh, when the number of chirps was 10, what the temperature might have been, that sort of thing. So that's what the line enables you to do. And to calculate the equation of the line, what you do is you eyeball the 2 points, any 2 points on the line, preferably one on this end and one on the other end. Like for example, in this picture, 10 seems to be about 40. You draw a straight line with a ruler to be more exact. Okay, so 10 and 40 is the first point. And then over there, 50 goes to what, 90 or something? So 50, 90 is your second point. And with that, you use the point slope formula and be able to come up with the equation of the line. And then you can calculate values of all other points exactly. So please do example, this is example 2, okay, which is on page 375. So please do example 2 as part of your homework. Anyway, I don't have that written down. Now, in general, then when we talk about eyeballing, that is, use human judgment to draw some random line, it's not going to be exact. But there's a computer way of doing things. Okay, there's a computer program where you can type in the dots by hand, which will take a while. Depends on whether you do it on a computer or on some graphics calculator, which is going to be a total pain to enter information. But it can be done. Okay, and once you enter it in, then the computer will draw the line for you based on the information using a computer algorithm that is taught beyond calculus. So we're not going to that's why I'm not going to talk about that here, but I'm just telling you that's possible. And if you need to, you can enter data in and the calculator will crank out a line for you. But we're not going to go into that. Okay, that is something that is not normally covered in algebra in my opinion, so I am just going to skip that. And so that's the end of this section. So for this section, please only do example 2 as your homework, and then we're going to skip the actual problems. And that's the end of section 4.3. Now, so let's now move on to section 5.1, okay, which is on page 400. And where we're going to do quadratic equations. The linear plotting graphs and eyeballing is not going to be mentioned again, okay, in the rest of your math all the way through calculus. Until you actually pass calculus, you take the class, I don't know what it was called, numerical analysis or something, where you actually teach you how to do the linear regression. Okay, and so if you're interested, please get through all the math, pass calculus, and then you can take that class and know exactly how to do the linear regression. So, but in the meantime, let's do quadratic functions, chapter 5.1 on page 400, where we are going to study the various, well, in this case, we're going to study quadratic function is a parabola. So we're going to study the various qualities of a parabola. Okay, now let's look at page 400, where we have a bunch of stuff like this, right? And we have the parabola, and then we have two x-intercepts, and we have, well, the parabola is the equation of any quadratic function. It might point up or it might point down depending on the coefficient of x squared. If x squared is positive, it points up. If it's negative, it points down. But we'll go into more of that later. The axis of symmetry, the parabola that comes from, which is the graph of the quadratic equation, is a symmetrical parabola, which means it has an axis of symmetry down the middle, okay? And then it crosses the x-axis at two x-intercepts, which we also call them the roots. Where you solve for the quadratic equation, that's why you're looking for those two x-intercepts. They're called zeros or roots, either way. And then where it crosses the y-axis is called the y-intercept, but that's not as exciting. And then the vertex of the axis of symmetry is the very bottom tip of very bottom tip of the parabola is called the vertex, and the tip will be at the bottom unless your parabola is it goes this way, then the tip will be on the very top, and that is called the vertex. So let's look at example 1 on the next page, where we are going to talk about a couple of things about this parabola. Now, example 1, we have what are we doing? So this is a regular parabola, okay? And the vertex, it looks, just judging from the graph, if you look at it carefully, then the vertex looks like is at x is at 3 and y value is at 1. Okay, that vertex right here. X is 3 and then y is 1. So 3, 1 is the vertex. And then the axis of the symmetry then is right along the 3 line, okay, x equal to 3. So imagine x equal to 3, then you can draw the line clear up, right, where everything, all x values equal to 3 and y value, we don't care what it is. It can be anything. So x equal to 3 would be the axis of symmetry. And then, another thing you might notice is the parabola is too high in the sense that it doesn't cross the x-axis. Okay, it's up there, floating up there. So if it doesn't cross the x-axis, it has no roots. Okay, in other words, it has no real roots. It still has complex roots, as we might remember getting the complex roots in the past. But right now, we only care about the real roots, and it has no real roots. And then, so because it's too high up. And then, and finally, it crosses the y-axis at some point. As you can see here, it crosses at 7, right? Y equal to 7. So 0, 7 is the y-intercept. That's that. Now the next, let's consider something like let's turn to the next page. Of course, before we turn to the page, we continue this 401. It does mention that, of course, the good old quadratic formula that I asked you to memorize a couple of chapters ago, which was, if you've forgotten it, please do so right now. The quadratic formula is minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, please memorize that. Again, if it has slipped your mind. There's no reason to memorize it except that it's something that you should do, okay, after studying algebra. It's the only formula you have to memorize. I can't think of another one that's worth memorizing, really. And, I mean, you will know it, but they are not as impressive to memorize, okay? The quadratic formula is long enough so that you can rattle it out and sound like you know what you're talking about. So it's very important to memorize the quadratic formula. Let's see. So next, so the quadratic formula, well, never mind that. The point is the axis of symmetry is given as as x equal to minus b over 2a. Okay, this is important for the homework, so please note this thing. Okay, what is the axis of symmetry of a parabola that's opening up or down? Then is x equal to minus b over 2a. It's that simple. Okay, that's the equation of it. That is, all right, and then everything else is, well, whatever it is. So let's flip the page, and I should mention one more thing. Now, once you figure out what the axis of symmetry is, I'm now on the following page, 402. Okay, now let's look at this particular problem. Now, once you know what the axis of symmetry is, the vertex, then you can calculate what the vertex is, the location of the vertex. And I suppose I should mention that the standard form of a quadratic function, this is on the same page. The standard form is f of x equal to a times x minus h plus k, x minus h squared. This is called a standard form, okay? And the reason it's called standard form is that if you write the quadratic equation in this form, then h is actually the h and k is actually the coordinate of the vertex. That's why we write it like this. So in this case, for example, h is minus 2 and k is equal to 4, as you can see. So it equals to x minus h. Remember that. And if it's x minus h, then h and k will be f of x equal to a times x minus h squared plus k. If you write the quadratic equation like this, then h and k is exactly the coordinate of the vertex. At least I think so. Yeah. Anyway, so having said that, let's move along. Okay, and we're gonna do something that has something to do with that. Where's the next example? So, all right. Now let's look at example 2. Write the equation of quadratic function from a graph. All right. So equation 2, example 2, I mean, which now we are looking at page 404. So example 2, we have a function, okay, whose graph is given to us, and we know it's some kind of x squared. However, it also got stretched and moved and that sort of thing, and we need to figure out what it is. But it's basically, it started out being an x squared and it got transformed. So let's figure out exactly what it is then. First, let's pay attention to the vertex. Okay, the vertex is, instead of normally f of x squared is at 0, 0. Okay, here's the normal graph of this thing. It looks like that. But now, so pay attention to the vertex. What did the vertex do? The vertex got shifted to the left. So in the previous section, we said that if if you shift f of x where x is being subtracted by a number, if the number is less than 0, we'll shift it to the left. And if it's bigger than 0, we'll shift it to the right. So then the f of x now, the shifting happens as f of is shifted to the left. So we have to subtract how much? By about 2. Look at the tip. The bottom of the vertex is at minus 2. So we'll have x subtracted by minus 2, okay? And then that would be equal to, that is the shifting. In other words, we have x, what I should say is that x squared, f of x is x squared. So x squared is being moved to a minus 2 situation. Okay, and then secondly, you notice the tip is down, okay, compared to the original x squared. Now the vertex is down by 3. Now the vertex going up and down, this is dependent on whether b is bigger than 0 or smaller than 0. And if b is less than 0, then it moves down. So then we have, therefore this is a subtracting by 3 situation, and that's basically what the parabola looked like. But that is not all. the parabola is also being stretched somehow. Okay, so the original parabola, we will call it this thing. We'll call it, okay, so the parabola, let's call it f of x equal to a equal to ax minus and so on. And so then it we just need to figure out what a is. So what, because the number a is the coefficient before the parabola, it compresses or stretches it. But how big is a? So what we're going to do is in this case we'll pick the point 0, 1. Plug in 0, 1, and then 0 minus 1. Okay, see the parabola crosses. The parabola crosses the y-axis at 0 and minus 1. So it's 1 point on there. So we just pick that random point and to calculate what is a, okay? In other words, y is f of x, okay? So the y value is equal to minus 1, and then x times a of x value is 0. So 0 in here, that's 2 squared is 4. Minus 3, which means a is equal to, so a times 4 equal to, that becomes 2, so a equals to 1/2. And that is the value for a. So then now we have the graph. The graph is equal to, well, your book calls it the g of x, which is fine. Let's call it g instead of f. One is as good as another. Since we already called f of x x squared, we'll call this thing a different name, g of x. So then g of x, then if you write the whole thing out, will be equal to 1/2, okay, times x. The minus is a plus 2 squared minus 3. This thing here is called the standard form. The reason it's called the standard form is because you can, just by looking at it, then tell that the vertex is at -2 and -3. And the graph is also being, I believe, compressed, being that it's only half, okay? So it compressed into half, so the thing got squashed a bit. But however, it is possible to change it back to the in a regular form. Instead of the standard form, we can change it back to what polynomials normally look like by multiplying everything out. So let's do that, okay? So that equal to 1/2, and then this is x squared plus 2 times 2 is 4. 2 plus 2 is 4. 4x plus 4. Be sure you know how to do this, okay? Expanding that to here. And then minus 3, which is going to be, all right, which is going to be 1/2 x squared, continuing doing this stuff. And then this is plus 2x, and then this is 2 minus 3 is minus 1, and that should be it, okay? So that is the equation of the graph in polynomial form. Polynomial form just goes number x squared. Standard form, they write it this way so that you can see the vertex at a glance, okay? The vertex is -2 and -3. Okay, so that is example 2. Now I should mention before we move on that on page 403, that the standard form of a quadratic equation. The standard form is, in general, see, the general form is just what we've always seen, but the standard form has minus h and plus k in there. The reason is because h and k are the vertex, the coordinates of the vertex. All right, now let's see. So let's look at example 3. Okay. Now you might ask, how do I know that is the coordinate of the vertex? There's a reason for that. Now you notice this equation in the standard form, we have a times x, ax minus h, right? Well, that's a squared, which means the smallest value of this, assuming a is positive, then the smallest value of the function f is where the square is 0, okay, and it equals to k. It's not possible for this f of x to get any less than that, right? Because if it gets any less, it would be, and because, well, k is the smallest value because the square can, at the most the square can go down is to 0. Okay, the square does not go any less than that. And so then as a result, the value of f of x, the lowest it can go is k. So that, which is why that is the vertex, is the y value will be at k, and the x values is exactly where the square equal to 0, that is x is equal to h. And that's the logic behind it. So having said that, let's look at problem example 3. Where we have we have a quadratic equation and we're supposed to find the vertex of it. Okay, so so let's see. We have, so the quadratic equation, the first, remember the axis of symmetry is the equation of the axis of symmetry is x equal to negative b over 2a. That is also the equation of h. Why? Because h is equal to x at there. Okay, so h is the x value on the axis of symmetry, so they are the same. So, and as a result, x equal to x, and in this example then, our f of x equal to 2x squared minus 6x plus 7, and then the h then equal to h equals to minus b over 2a, so we'll calculate that, minus b, which is 6 over 2 times 2, so that equals to 3/2. So h equals to 3/2, and the k is equal to, then next we'll calculate k. K is equal to f of x, f of h. So k is h is the coordinate, the x coordinate of the vertex. Okay, now k, if you put the x coordinate in, it's going to give you the y coordinate. F, okay, that would be equal to this thing, etc. Let's calculate this thing. So 3 over 2 squared minus 6 times 3 over 2 plus 7. So then, so as a result of this, then we will, well, we'll just calculate this stuff out. Okay, and so that's 9 times 2 is 18 over 2, which is just 9. Okay, that's 9, and plus 7. So h should be equal to, k should be equal to, am I missing a 2 here? Yeah. Okay, so 2 times 9 minus 6. Let's see. All right, I have a mistake here. I know that doesn't sound right. Is divide by 4. That's better, right? So then that by the time that's done, it gives us why do I have no? Let me fix something else. That is 9, for heaven's sake. Okay, that's 9 over 4. Minus 9 plus 7. All right, that is 9 over 2. That's 9. That's 7 minus 9 over 2. 2. 9 over 2, right? And that should be equal to 502 or something. Yep, it is. All right. So that is equal to the value of k. Now, so the next thing we need to do is, once we have h and k, we follow the exact formula of the standard form. The formula is right here, okay? If your function is f of x equal to ax squared, etc., then f of x, the standard form, you copy down the a and then do the x minus h, and then there's the k. And that's how you come up with it. So the function then is equal to f of x equals to a, which in this case is 2 times x minus h. H is, where's h? Right here. Squared, okay? For following the formula, see? X minus, a times x minus h squared plus k. Plus k is 5 over 2. And this is the standard form. Is it so? Yep, this is the standard form of the quadratic equation. Okay, let's see, what else do we have? And that should be, let's see, I'm at the wrong page. All right, so here we are. I'm on page 406. So finally, we have got to the answer of this example. Now, next, let's consider the domain and range. The domain and range is nothing that we don't know about. The domain, of course, for any quadratic function is all real numbers, okay? You can plug in anything in here and calculate this thing and have something come out. The range, of course, is more limited because the quadratic formula goes down and go back up, right? So therefore, the range is only from down to the vertex. That's it. It doesn't go any lower. It's not possible. So the range is going from whatever the vertex is on up. If the parabola is pointing up, and of course the parabola is upside down, then the range is from the vertex going all the way down to infinity. So that would be the range and domain of a quadratic function. So next, let's look at example 4. Find the domain and range of this particular function. The domain, as I mentioned, is anything, right? All real numbers. The range, to find the range, then we have to find the vertex. And what is the vertex? Let me erase the board first. So we need to find the range, and the range is well, the parabola is upside down because of a negative sign in front of the x squared, which means is this kind of parabola. And then it's we need to find out where its vertex is, because the k value is at the top of the range. Okay, the range will be from the k value all the way down to infinity. So to find the k value, then we start out by finding h value. H equals to minus b over a. Over 2a, all right? So knowing that, then let's find out h is, because from h, then we can figure out what k is. So h is equal to minus b over 2 times a, which is equal to minus 9 divided by minus 10 is 9/10. So then k is, to calculate k, we plug h into the function f, okay, and just evaluate this thing. So then k would be f of, let's see, what is it? 9/10, okay? And so now we just have to be patiently calculate this stuff. There are calculators that can allow you to do this by punching it in, but I highly recommend that you do this yourself, okay? And especially in the algebra course, because that way it helps you get good at doing this type of thing, which is required in everything after algebra as well. And let's see, 9/10 is a good practice. And eventually, by the time you get to calculus, then sometimes you might want to just plug it in because you've done enough of it. But right now is the time to do this type of thing, okay? So 9 times 9 over 10 minus 10, that's a 10, minus 1. All right, so that is there's not much interesting going on except that we need to crank this thing out. So we should probably use a calculator, okay? And so let me type this thing in the calculator, and you do the same yourself. So I typed it into the calculator. Here we go, and I hope you can see this okay. Now notice that the 9 over 10 squared, be sure to put that in parentheses, of course. And the squared button, my calculator has a square button that's called x to the power 2. See, can you see? And your scientific calculator should have something similar, okay? If I block my face out, maybe you'll zoom in. It doesn't want to zoom in. There it is, okay? So you push the x squared button on your calculator. Well, anyway, so once you've done that and type everything in, okay, the 81 divided by 10, and then you come up with, my calculator came up with a fraction by the time everything is typed in. Let me see, is this right? Yep, and according to the book, that must be correct. So that's the answer of that one. Next, we are going to determine the maximum or minimum value of a quadratic function. What does that mean? Oh, sorry, I wasn't done talking. Because just because we figured out what this thing is, what was it? 61 over 20. So this answer is 61 over 20, but what does that mean? We were originally trying to figure out the range, okay? So the range is going from 61/20 down to negative infinity. So the range should be minus infinity, comma, 61 over 20. Yep, that is what the book says. And the range includes the 61 over 20 because the vertex, that's the y coordinate of the vertex. So that is our entire range. Next, let's calculate the maximum minimum value. What's the maximum minimum value? Well, it is exactly this thing that we just did, the k value, that is. So let's do that, okay? The function, that's, what are we doing? Example 5. Okay, so let's look at example 5. Example 5, right. I'm looking at example 5 on page 407. So example 5, let's read this thing, okay? Some farmer has a backyard fence, and she wants to enclose this a small area by fencing it up and using it for some purpose. And so she bought a total of 80 feet of fence, okay? So the total is 80 feet of fence. Total fence is 80 feet, 80. And then she wants to enclose it in such a way to maximize the amount of fencing she uses and not waste any fencing, which doesn't sound like a smart thing to do. Shouldn't you be maximizing the land, not the fence? I mean, who cares about the fence? But in this case, we care about the fence, so therefore we're going to do it that way. So to do that, then, of course, we have this side is x, and that side is also x. We'll call the side x, well, we just do, okay? And then, well, your book calls it something else, which is fine, but I like to call it x. And then what's left here will be 80 minus 2x, right? So, because you're only doing this part, okay? This is the backyard fence, so that's already there. And so, and she is dying to save as much fencing as possible. So then we have, so if this is so the total amount of fencing will be x plus 80 minus 2x, which is 80 feet. All right, so then the area of this thing that she is doing is x times 80 minus 2x, okay, length times width, which is equal to the area of this, which is our function, and we want to choose x in such a way that this area will be maximum. So so she only wants to, well, you'd think that you would just simply get the biggest area and then buy enough fence around it, but I guess not. Anyway, so anyway, knowing that, what is the maximum of this? This is a quadratic function, okay? You can see because the minus 2x squared here is a negative sign, so this function is like this, so it has a maximum value. And being that, then the maximum value, let's write out the function first. This is minus 2x squared plus 80x. Then the maximum value will be at the vertex. In other words, we're calculating k. To calculate k, we first calculate h. So h equals to minus b over 2a, says right here, okay? So minus b over 2 times a, which is minus 2. So that equals to 80 times 4 is 20. So h is 20, which means k equals to, plugging, k is f of h, okay, f of 20. So we're going to need to plug 20 in here. So that's 20 times 80 minus 2 times 20, that's 40. Well, I'm out of space, so that's 40, right? If I didn't mess up. So plug 20 in here. 40, 80 minus 40 is 40. So it should be 20 times 40. All right, so that is, so k equals to then 800. And that is, whatever that is, square feet. And that should be the maximum, okay? Because that's the highest this parabola is going to get. And therefore 800 square feet is the maximum she can enclose if she doesn't want to spend an extra dime on the fencing. And that is what it says. Okay, the maximum area is k equal to 800, which occurs when x is equal to 20. And well, anyway, that's that. All right, so let me erase the board. Next, let's look at example 6 on page 409. We have a situation where we have subscribers. Okay, at $30 per cost of the magazine, we have 84,000 subscribers. Now, if we raise the price to $32, then we're going to lose 5,000 subscribers. So we're down to 79,000 subscribers. Now, so then we'll call this the charge, okay, the cost, whatever, and this is subscribers. And so we have, what we're trying to figure out is how much should we charge so that we can maximize the number, which is charge times subscribers, which is the revenue. That's how the most amount of money we can bring in. So to do that, first we need to find the relationship between the charge and the subscribers. And assuming that it's linear, we do that line trick. Okay, so we are going to calculate first the slope. So the 2 points are 30, 84,000 and 30, 79,000. So we'll write down, let's see, 30, 84. I'll save on the 1,000, okay? And then 32 and where's my 2? And then 79,000. And then bear in mind that these are in thousands, all right? The y value are in thousands. So then, let's find the m. M then equal to m. The slope is y2 minus y1. Okay, 84 minus 30. My 3 is nothing to brag of. Does that look like a 3? Kind of. Y2 minus y1 divided by x2 minus x1. Wait a second. Sorry. This is y2. Let's get rid of that. Anyway, so y2 minus y1, okay, that's better, minus y1, and divided by x2 minus x1, we'll start here, we'll call it starting here, so this is x2, 30 minus 32. That will be equal to, so the slope will be equal to 5 divided by 2, right? And is equal to 2.5. That's 1,000. Remember that. Because these numbers are in thousands. So this is 2.5. That is, 2.5 thousand. And anyway, and then we need to write the equation. This is, I should probably write down what these things are. This is C, comma, S. Okay, C1, we'll call this C2, S2. And the second one will be C1, S1. So the slope is S2 minus S1 divided by C2 minus C1. And so now that we got the slope, which is 2.5, we will then do the y value, which we call S this time. S equal to the slope, which is 2.5, okay, times, sorry, it should be S minus one of these things. So S minus S1, we'll pick, what's S? S is this one, okay? This is C, and this is S. So let's pick this, we'll pick whichever one of them. Let's pick S minus 84, okay, equals to 2.5 times c minus 30. Okay, whereas, yeah. Okay, so then as a result, this is the relationship in which we will clean this up a little bit. So S equal to, we'll put the 84 on the other side. So 2.5C, and then minus 2.5 times 30, and then plus 84. And so that cleans up to be S equal to 2.5 C. And then the rest of the stuff we need to do. What is 2.5? 30, 60, 75. Okay, minus 75 plus 84 is, so minus 75 plus 84 is 9, right? Yeah, so the equation between S and C is that the subscribers is equal to 2.5, okay, 2.5, and then C plus, did I say 9? Yeah, I think so. And these, the 2.5 means these units are in thousands, by the way. Okay, so here's my equation, and now that we know our the relationship between the charge and the subscribers, that is, if for each for however much you cost, the number of subscribers will be 2.5 times the charge, say 30 or something, plus 9 in the thousands. And well, anyway, yeah. So having said that, then we're trying to maximize the value of C times S. So C times S, the function C times S then equal to C times, okay, we'll plug the S in here. S is 2.5 C plus 9, and that equals to, let's see, so that is 2.5 C squared, okay, plus 9C. Now so we have to calculate the maximum, which is again using this particular formula. So let's do that, which is okay, then the H value is equal to minus B over 2A minus 9 over 2 times 2.5. That is no. Now I made a mistake here because this equation needs to be negative because we're maximizing those, so the parabola should point down. I made a mistake right here. See, this is the m is negative. See, 30 minus 32 is a negative value. So this should be negative, and that changes things. So I will continue this in the next video.